Hey guys, this video will be a continuation on the last video where we discussed unitary matrices and Pauli matrices. And the Pauli matrices I introduced will be part of a larger group of operations that we call unitary operations. And that's what this video will be about. Basically, operations made up of unitary matrices. So the first type of unitary operation we talked about was Pauli matrices, and we talked about the basic contents of what a Pauli matrix is in the last episode. But so generally these matrices are called X, Y, and Z. That's not how you write a Z. And they have some special properties. So let's tackle each one by one. So the first matrix X, and that has nothing to do with this over here, that's just talking about what a Hermitian matrix is. This matrix X is also called a bit flip matrix. So we can do X on ket 0, and that gives us ket 1. We can do X on ket 1, and that gives us ket 0. Feel free to verify with the bra structures of ket, the ket structures of ket 0 and ket 1 if you like to yourself with matrix multiplication. And then the Z matrix, the Z Pauli matrix, is called a phase flip. Now what this does is if we apply it to ket 0, so these are both called bit flip operations, and these with the Z matrices, this does not flip it. So ket 0 is now ket 0, but if we operate on ket 1, we get negative ket 1. And these are called phase flips. Yeah, so that's what each of these does to a ket, either ket 0 or ket 1. Now, the second type of unitary operation is called a Hadamard operation. And I'll explain more in the next video, which will be a continuation of this one. But right now, I'll just give the basic definition of what a Hadamard matrix is, because in order to explain its significance, it needs a little bit more context and a little bit more time. But basically, it is a unitary matrix, and you can check this definition out for yourself if you'd like, that has this structure. Yeah, and we'll continue in the next video.